Welcome everyone. It is the second video for the regional analysis course in which I will introduce you to the methods of microscale mapping, the social area analysis. We are going to make maps about aging and economic or social status differences in the capital city of Hungary, Budapest. But first of all, I will introduce some conceptual or theorizing notions. But after that, we are going to calculate three indices, one local and two global indices. I will show the difference between the global and the local indices. These will be important for the course, to understand how which is the difference between the two form of indices, but let's not rush so far ahead. Let's start with the concept of social area analysis. The social area analysis is a theory and a technique for analyzing and mapping microscale differences within the urban environment, because the metropolitan areas have a very heterogeneous and diverse inner spatial structure due to the location of buildings, neighborhoods, transportation entries, accessibility to the public goods, to the urban green. Regarding all of these, the spatial structure, the inner spatial structure of the metropolitan area have a very diverse picture. Based on these locational differences, different social groups are not evenly distributed in urban environment because they have different needs and different material resources for the housing, for the estate. For example, large families require large estate, or young students like you want to live near to the university, near to the nightlife, so the large families move out to the metropolitan areas or the city center, or and the students or the busy businessmen move to the city center next to the main buildings. In addition, there are huge differences in property prices in different parts of the city, so not everyone can afford the area, those area that would be best for them. So there are a lot of things and processes that you depending on how and where can you live. Social area analysis is used to map and measure, and the most important, quantify the spatial differences and segregation of different social groups, such as ethnic, economic status, or aging differences, which is in the slide in there. We are going to deal with economic status and aging differences within the capital city of Hungary, Budapest. But before that, let's take a look at an example of ethnic segregation. The map clearly shows the different ethnic segregations in Detroit. While blacks tend to be predominant in the northern part of the county, while the whites are in the larger southern census tracts. The area size of tracts is likely to indicate the population density. These are the larger census tract than the northern part, as there is usually similar number of people in such a census tract. In those census tract, there are similar number of people than there. So the white people in Detroit, most of them live in low dense areas, large housing estates, for example, but Hispanic and black people, most of is living in a dense area in Detroit. But how do we collect and store information and build databases for social area analysis? Due to the personal rights, we collect information about individuals in geographical aggregated spatial units, as we saw in the previous figure in here, because in the orange ones means that the white people are living in the most, and just the number, the comparison between the ethnic social groups appearance in the map. So our unit of analysis in this case is therefore not the individual, but the geographical defined area in which we have information on the social composition of the living population. For example, the previous map, the ethnic composition of the living population. We know how many black or white people live in there, or how many children, middle age or pensioner live in there. For example, for the aging mapping. And using these data, we can make several scientific statements about the structure and the transformation of urban environment and urban society. I know that not only settlement developers, but also physical and environmental geographers listen to this, so I tell them that the following indices are not only useful for social researchers, but can also have many other uses in physical geography if you work with territorially or spatially aggregated databases. So the diversity index, the dissimilarity index, and the segregation index also useful for any kind of physical and environmental geography example as well, researches as well, because we are curious about the spatiality of some spatially defined notion. In this case, we are curious and we are dealing with social groups, different social groups, but if you have or any kind of plant or something else, you can use for these indices the following indices. The first index is the diversity index. which measures and quantifies the degree of mixing of different social groups in each spatial unit. And here, this is the important thing in this course, because the diversity index is a local index, so we can calculate a value of each spatial unit. We can calculate a value for diversity index for each spatial unit. So this is the description of or the definition of the local index. If you can calculate all of the spatial unit, the index, those are local indicator. Those are local indices. Diversity index is a local index. So we can map the spatial differences of the diversity of several social groups. The next is the dissimilarity index. This is a global index. So if you have two different social groups, you can quantify and measure the segregation, the degree of segregation between these two social groups with one value. So for whole observational area, so this is a global index, the dissimilarity index. So you have only one value for the whole observational area, not each unit. You haven't any value for each unit. You just have one value for the whole observational area. And the last one, the segregation index, which is similar to the dissimilarity index, but here we calculate the degree of segregation of one social group to the complementary groups to the others. So we use only one social group in the segregation index, and we use because here it is A is the first specific social group, and the second is the B in this formula. In this formula, we indicate these social groups in that way, but in the segregational index, the A, let's talk about A social groups, and the B one is the complementary A. So all of them who's not A. This is the definition of the complementary group. So we are going to calculate all of three indices, but before we start calculating these, two concepts must be mentioned that define the inner structure of metropolitan areas. First is the suburbanization, when mostly the people with family move out of the city center. But be carefully, because not everyone calls suburbanization when the moving remains within the administration boundaries. But we will see about such suburbanization within the administrative boundaries within Budapest. If the moving does not cross the administrative boundaries, we call it inner suburbanization. So we will see some inner suburbanization processes during this course, during this class. And therefore the rate of young population, because families usually move in those areas. These are the typical pictures of North America suburbanization, but similar pictures can be seen in Hungary as well, but not that uniformization form, but similar. The second one is the gentrification, when the downtown of the city center, with degradation and the lower social status, lower economic status, are given a new function, so that the residents of the previously with low economic status living there has been pushed out. There are conflict zones in the city center, in the edge of the city center, in the edge of the downtown. Because there are a lot of areas with the degradation, and the capital want to use it, and some businessmen wants to use it for another function, for another using. So this is two concept, two notion, which are I've heard you've heard these notions from the Space and Society or social geography courses. So I'm not discussing so much for these notions. Let's take look at the calculations of these indices and mapping the social differences within the urban environment. So open the Quantum GIS software, and the first task always the saving the project, because if you don't save the whole project, the whole work can be trashed, can be crashed with the Quantum GIS. So save, and here is my folder for the regional analysis and for today, and February. Yeah, okay. And after that you should add two vector files which is in those zip file I will upload it to the CoSpace. So browse, and database in Budapest and districts in Budapest. Add it and add also. Okay, we have the map we have spatial units for Budapest. We have 790 spatial units for all of the for the whole Budapest. So we can make a very good resolution map for the inner structure in Budapest. If you look at it, the districts in Budapest, this is an official distribution of administrative boundaries. There are 23 districts within Budapest. Every districts have an own local government, but this database is has a better resolution for creating some social differences map. So we are using these, but districts in Budapest is useful for that to symbolize and visualize the location of each unit. So grab to the top of the layer and right click and properties. Here it is. We can make a no brush fill style and a stroke width, make it greater, for example 0.4, apply, OK, and here it is. We only see the boundaries of the official administrative areas. We and the decision makers know the official boundaries, but doesn't know the census tracts. So we can just making a better understandable map of the visualized the boundaries of the official districts. We can see the database with open the attribute table. Select the database in Budapest and open the attribute table, and we have a lot of information for all of these spatial units. First of all, we have the population number for 2011. This was the last census for Hungary. The next one will be at 2022 because of the COVID-19 pandemic. It will be delayed from this year for the next year. So we have almost 10 years database, but this is the all of we have, and we have an aging attributes. For example, population number between 0 and 14 age. We have 15 and 24. We have the middle age and above the 65 years old people. The pensioners in Hungary, we have pension year deadline in the 65 years, and we have an ISCO classification for all of the employment. ISCO qualification is the international standard classification of occupations. So this is the classification for work, for the type of work for the employment. The first and the second category, which appear in that column. This is managers and professionals. So economically, these are the highest status. These are the employers with the highest social and economic status. So, and we have 3, 4, and 5 class of occupations. 3 is the technicians and associate professionals. 4 is the clerical support workers, and 4 is the service and sales workers. So the not unofficial name is the technicians. These are the middle, economically middle status, and here is the 7, 8, 9 classes. So the craft and related trades workers, plant and machine operators and assemblers, and elementary occupations are these employers. So the lowest, economically the lowest status employers. So, and we have lots of other attributes, but we are dealing with these two attributes and social indicators, two kind of social indicators. So first of all, we are going to calculate with a field calculator the share of the elderly, the pensioner population, and for the youngest population. This is the aging index, which is so open the field calculator, and the aging index is a comparison how many elderly people compare to the number of youngest people. So we can add a new column with the field calculator. Output field name, let's take aging index. I'm not able to make and finish the output field name with the next, because the column name, the maximum character of the column name is 10 characters. So we just make these small words for the column name, and fields and values, and pop 65 divided by the pop 0, 0 and 14, and double left click, and multiplied by 1000. So for the percentage form. So we have we have these form for the aging index, and OK. And save edits. This is important for and toggle editing mode, and we have the aging index, and this form, this percentage form, for example, the 200 means we have 2 times more elderly, older people in that spatial unit than children. So how does it look like in the map? Right click for the database in Budapest, properties, and symbology tab. In the symbology tab, select the graduated symbols, and the column you have to select the aging index. Okay, aging index, and not equal interval. You should select the quantile equal count classification and apply. Okay, so here it is, the spatiality of the aging index. So we have a very old downtown, and we have an outer ring, the suburbanization, inner suburbanization ring in the outer Budapest, because where in those where there are a lot of children, there were and there are the families as well. So so we have such spatial structure. We have, and this is a very interesting structure. For example, here it is. These are the flat large estate buildings, flat of houses, and these are also panel buildings, so-called panel buildings, and these are very unfamiliar, unsimilar, so not similar to each other, because these flat of houses contains a lot of low-income families, but these large estate houses have so-called old ghetto, the pensioner ghetto. So in the similar type of buildings has a different types, often has a different types of social groups. But after that, let's take a calculation for a diversity index for the occupational classes. Before that, we just map the share of the highest status. So also the attribute table, and the field calculator, and high status, for example, and whole number is okay. Oh, not okay. Decimal number, and the precision should be 2, because in this case we add that number which we want to visualize after the decimal point. So we have to add the ISCO 0, 8, 1 and 2, and divided by the employment, because only the employers included to the ISCO classification, because the ISCO classification for works and occupations, not for all of the people. For example, students haven't any ISCO classification. Students or children and pensioners also haven't any ISCO classification, and unemployment people also haven't got any. And also multiply 100, because the percentage form, to the percentage form, and okay. Here it is. We have how many percent of employment in those spatial units have high or the highest social status in Budapest. So save also and toggle the edit mode, and also you should save the project as well by time. Database in Budapest. Double left click also appear the properties. So the column we should select the high status and classify also and apply. We have these division, these distribution of high social status. We have a very huge area in the Buda side, in which those areas, the Hungarians name it Buda Villa district, because all of these areas characterized by huge villas and large family or detached houses. So these are the distribution of the social status. We have a very low number of high social status in the southern part of Budapest. So after that we should calculate the diversity of these classifications. So also the attribute table, and open the field calculator, and ISCO div should be the name for the column, and not the whole number, the decimal number, and precision should be maybe 2. So what was the formula is the diversity index. In the upper part, we have the number of population of group I. In this case, the groups will be connected to the ISCO categories in unit G. So in this case, we should ISCO 1 and 2 multiply by the ISCO 1 and 2 minus 1, and the summary appear in the beginning of the upper part. So sum the ISCO 3, 4 and 5 and multiply by ISCO 3, 4 and 5 minus 1, and sum plus the ISCO 7, 8 and 9 multiply by ISCO 7, 8, 9 minus 1, and the brackets, we should use brackets all of these. We can see it. Okay, all of the brackets are the right place, and divided by all of these the total population. In this case, not the total population, just the employment. So employment multiplied by the employment minus 1, but we should use brackets in this case also. And this is the formula for the ISCO diversity form. Okay, and okay. And here it is, the diversity value for all of the spatial units. Save it and exit to the editor mode. And we should map the spatial characteristics of the ISCO diversity. So click on the layer and the column ISCO diversity also, and classify. Okay, but equal count is not the right natural breaks. Okay, so we have very low diversity in those areas where the high social and economic status are live. So the other parts of the city we have greater, in the suburb also have a greater, and in the edge of the downtown, which is characterized by the gentrification processes, we have very diverse, with a white color, characterized by the high diversity, because a very different social status people live next to each other. But in the Buddha Villa district, we have a homogeneous area, homogeneous part of the city. So we can measure the diversity of these occupational category, and we can create a map of for these spatiality. So we are going to create a map, new print layout, ISCO diversity, okay, and here it is. Budapest has a compact form, so we can draw, okay, we can add the map, what we can see in adds a new map to the layout option, and draw an extent, yeah, and in the item properties we can set the position and size. We can add a square size, for example 200 and 200 as well. So after that, in the layout tab, we can resize the layout. So just add to the map size to the layout, and in the item properties select the map part of the layout, and if you just select the move item content, we can move the map material, and with the scale, with the change of the scale number, we can change the zooming of the map. For example, to 100,000, but not enough. 170,000, for example. Yeah, this will be good. And select move item, and select nothing to unselect the map item in the layout, and add a legend. Okay, we have a legend, and we can rename the layer diversity of economic status, for example. Yeah, and administrative boundaries of Budapest. Yeah, and if the map is crossed the legend, just click on the map and select the move item content, and move the map to the right place, and after that select move item, select the legend, and in the item properties we can unselect the item, the background, and here it is, the good form, not the crossing form of the boundaries, but here it is, the crossing, and a greater scale, so I can move it, yeah, away. And missing parts, new scale bar, for example, yeah, north arrow, yeah, and the title of the map, the speciality of the of diversity of economic status in Budapest, Hungary, for example, and center, middle, and the font should be greater than now, for example, Arial, bold, okay, yeah, and one missing part left, the creator name, created by your name via Quantum GIS at 2021. Data source should be the Hungarian Central Statistical Office, yeah, and the coordinate system, HD 72 EOV EPSG 23,700, yeah, not justify for the left, yeah, and okay, this is a good map for visualize the spatiality of diversity of economic status in Budapest, Hungary. Okay, and export as image. ISCO diversity is a good name for this map. Okay, so after the calculation of the diversity index, we should calculate the dissimilarity and the segregation index as well. For this, we cannot calculate in the Quantum GIS because these indicators are global indicators, so we are not able to calculate all of and each and every units and each and every census tracts. So we have to use the Excel file, which also included in the ZIF file, and we have the same database as we can see in the attribute table. In the view tab, freeze the top row, so we can see the top cells. So we are curious about the dissimilarity, the segregation between two social groups. The two social groups should be the children and the elderly people as well. So what is in the formula? we have a number of population of group A, children, in a unit G, and the number of total population of group A in the observational area. So we have to make a summary of all of the children in Budapest, sum C2 and C 791, all of the children in Budapest. And if you grab the left down, we can calculate all of the number of social of aging groups. And after that, we have to calculate the division of each and every units. So we have to divide it by this number, and all of the case divided by, I say divided by, all of the case the summary. So we have to freeze it with the dollar sign before the number form, the cell number, and OK. And if you double click on the down, the left down in the cell, you can calculate all of the units. Make it to the elderly people also. So divided by the summary, dollar sign, and OK. Double click, OK. We have these two numbers for all of the spatial units. OK. We have to make a difference between these two numbers and an absolute value. Absolute value is make it not negative. So every negative numbers should be multiplied by -1, and every positive number remains it. So this is the absolute formula in this case. Okay, but in Excel we have an absolute formula, EPS and bracket, and make it a difference Z2 and minus AA2. Okay, and make the summary of these. So we have the dissimilarity index between the elderly people and the children one. So we quantify. No. Sorry, but we have divided by 2 number also. So we have to divided by 2. Yeah. So this is the dissimilarity number of these 2 social groups. Okay, and just the high social status remain. For we measure the segregational index for the highest social status. Okay, here it is. This is the segregational index. So we have to make a complementary number. So we have to insert a new column before the ISCO 3, 4 and 5. Insert sheet column, and we have to make a difference between in ISCO 1 and 2. Employment minus ISCO 1 and 2. This is the complementary number of the high social status. So this is the number of people who are not in the ISCO 1 and 2 category. Double click on it and make the dissimilarity index for for these two numbers. For it, we have to make the summary. All of these two groups, all of these two numbers. We have 260,000, almost approximately 260,000 high social status people in Budapest, and approximately 500,000 not high social status in Budapest. So we can just make the difference in one cell divided by the summary of its own summary. Make a difference K2 divided by the summary, freeze it with a $sign, and make an absolute formula. Okay. In this case, we make it with using free cell. In this case, I'm just using one cell for calculating this. Okay, and double click on it, and I can make a sum and make the dissimilarity index also. So the high social status people have highest or higher dissimilarity index than the elderly and the children has one. Okay, and after that we have to divide it by 1 minus x divided by t. X is the group X, so the high social status member. Okay, divided by brackets. This is a important things. 1 minus ISCO 1 and 2, the X group, divided by the employment, all of the population. So this is the segregation index for the highest social status. Okay. These for the today exercises. If you make the calculation, you should upload the Excel file, and you should upload to the CoSpace the database in Budapest shapefile, all of the regarding files, because database in Budapest has CPG, DBF, PRG, QPG, SHP, SHX file, so you should upload all of these files to the CoSpace, in which I can make the corrections of it. Okay, and also the ISCO diversity map you should also attach in the CoSpace exercise, in the CoSpace task. So thank you for your attention, and let's do and let's upload the files. Thank you.